pump to be optimized, I can select these pumps. But during optimization, I need to give it like my constraints. So during my constraints, I'm gonna say, well, if I have pressure constraints for all my network, and then I can give it a minimum maximum pressure, a velocity constraints, and how many I allow the pumps to start and stop. For example, my maximum
Inaonekana. So ni mchio
is
kabisa hii.
5 times per day.
Oh, so unaonekana hapa.
Yep.
Cheka hivyo, cheka hivyo.
Pia tunaweza ukikuwa nusu kabisa.
And also, I have a minimum at the tank and maximum at the tank.
Before tufike hapa.
And then I can give the tank minimum, maximum here. And then when I'm done, I can compute my model. Sorry, that is steady state. And then when I'm done, I need to understand how much I'm gonna pay for electricity and how my pump will operate. And in that case, we can use the scenario energy cost. And then in the energy cost, I can build my tariff, either constant or a variable tariff. And then I can compute, and then I can get for each pump what will be my daily cost. So this is my daily energy cost. For the pumps, whatever I want, like at what time it happened, and then what is like my, let's say, accumulative energy cost, and how I spend these. So all this information, I can find it in here. Let's move to the design. So let me add. Well, new file. Let's say designer discussion. All right. And let me have a look at my scenario. All right, so let me delete these two. I don't need them in this color. All right. I got a network here. And all these pipes that is colored, they are as-built drawing. However, I have a path where I can place my pipe. For simplicity, at the time being, I add it as a 1-inch pipe. See, if I double click over here, you can see that it's a 25.4 millimeter. All right, so any gray color pipe you can see here is just a path where I can place my pipe. It's all 25 millimeter. And now we need to understand what's going to happen if I add 189 liter per second at the junction 500. At the time being, junction 500 is at 0. And it's at 0 demand, and the system is running fine. Okay, so let's run the system and check what's happening. If I compute, and I can see that there is no problem because I didn't add any extra demand at the junction 500. If I go to the flexible table over there, and I double click on the junction, and I go to the pressure, if I check the pressure range, and then I can see that my maximum is 810 kPa, like almost 8 bar and 2.7 bar. All right. Now I'm gonna ask the system, all right, what will happen if I add 189 liter per second over the junction 500? Good question, but it's not gonna be a good answer. Because if I make this current and then I compute and say, negative pressure pump exceed its maximum operating point and a lot of problems. And if I get to the flexible table to check my junction pressures, it's gonna give me something like unbalanced network. Like, I don't care what this number is, but it's an unbalanced network, all right? So now what we need to do is to redesign it to have 189 liter per second at the junction 500 and without affecting the network. All right. So how to do this? I have drawn my pipe network over there. And now I need to start to ask the system to optimize the design for me. And how do we do this? We get here something called Darwin design. All right, so let me delete this design. It's an old one, but also I need to delete this design group because they don't relate to here. And let me start. So I need to tell the system the story in a step-by-step. And the step-by-step is a tab, is like here. All right, on a tab by tab. You have to go through them one by one. And then I'm gonna create a new design, optimize design. And then the design events. What the design events is, let me tell you. This is a new design event. First of all, I need to adjust the demand. So I'm gonna
Hello. 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 Hello.
tell my system the junction 500, 89 liter per second. Junction, all junction should fall between a minimum and maximum pressure. Let's have like 1.3 bar, for example, as a minimum. It depends on my design criteria. And I'm gonna tell my system, listen, first pipe group will be must loop. And then in there, in my design, to loop my network. North and south. All right. I say, well, I'm allowed to change the pipe size per one, yeah? And I put them in group. Oh, I'm gonna get them from the south. And don't forget that I put this pipe in the must loop, so it's in a different group. And pipe duplicate is not allowed here. And then I build my design group. I have my cost property here. So I get the must cost. That is the pipe that you're going to design from. And that is their cost per meter. And that is the optional. With the optional, I have one with a 0 diameter here, so I can take it out of the network. And then I'm going to go to the design here. In the design, here I'm going to assign that this is a must, and the other pipe are optional pipe. So the must loop is an optional path. And I'm going to go to the options. I say, well, put 50,000 trial, keep the first three solutions, lowest cost. I'm going to compute. It will go and start searching for lowest cost. And it's going to tell me that my lowest cost is $175,000. And that's solution number one. If I click on solution number one, it brings the water from the north at 200 millimeter, and it brings the water, and the loop is at 200 millimeter, and then west and south will not be there. If I export this scenario as Nairobi in June design. Sorry. I'm correct. And then if I close this one, and then I'm gonna find a scenario. You can see that's the north path now. Have a different color, yeah. You can see here that is my HD. It was gray. It was 25 millimeter. And now if I change the scenario, it is a 200 millimeter ductile. And now let me run and compute. I deliver 189 liters per second to the junction 5.
This meeting is being recorded.
And why this is a part of optimized for the lowest cost. But I need this line. I need to cancel all this trial and error, which is like the 50,000 trial that I have gone through. But I don't want this one. I want the full line, and I want to decide where I want to stop. And then in that case, you can get back.
This meeting is being recorded.
To who? It's to your best customer. And in this case, Junction 500 pay part of the money. So we're going to consider the pressure benefits over the Junction 500.
Online yaonekana. Online. Hii presentation.
And I'm going to give it a budget. Rather than minimize cost, it's a multi-object trade-off. Normally, I multiply by 3 the budget of the lowest cost. So the lowest cost was 175,000. $500,000 is fine. 600,000.
At least right now everything is still.
And then I'm gonna go to my optimized run and compute again. Sorry, 1 second. I forgot again. Let me finish. It's gonna take
No PM.
2 more 3 seconds. This went from 3 solution to 20. Maybe it's fine 20, maybe it's fine 15, 10. I don't know. When I run it, it goes for multiple. So this 50,000, it's your nodes here. That's about what's the 50,000 over here. Means. And now it's fine for me. Intuition is my on one of the solution, and I say graph my Pareto front. That is my Pareto. So I can manage to do with 175,000. But I can add a little bit more money and jump with the benefits. While here, I'm adding a lot of money without benefits. So if it's come to me, most probably I'll stop at solution number 5 or probably solution number 8. So if I have a look at this two, solution number 5, it brings the water from the west and at 400 millimeters, so I can export this one. I'll call it S5. Easy, man. Sorry. And solution number, what would we say solution number what? Solution number 8. Solution number 8. Also from the west. Let me check the other solutions. Let me export it as well. It's 13. And if I close this one, if I click on S5, I'm going to bring the water from the west. And these pipes will be inactive. So if is active is equal. I'm going to bring it from the north and the west. And solution number 8, it's also from the west, but at a different diameter. Let me batch run the scenario.
Sijui kwa tunaweza fanya hivi, tunaweza mtoa hapo.
And we can go to the flexible table again, to the pipe, and then we can see here what is our, sorry, to the junction, to see our pressure. So if I go to the junction over there, and I can see my pressure, that is how it's vary between the solutions. And all my pressure will be okay, and my network is really optimized to my needs. This is what I want to say about water gems.
So presentation.
If you have any question, can you please raise it up?
Itakuwa tu monitor online.
Situmie
nikutumie nani ametuma
Am I on light? Can you hear me? What's your phone like? Oh.
Yes, I can hear you.
Can you hear me? All right. Sorry. That's good. All right. So this is what I want to talk about water gems. I think I take a lot of time. Now, what I'm gonna say that I'll be in Nairobi in September for a water gems course, and for the water gems course, actually, that is like
anasikiza
what we do
laptop.
in the. So it's gonna be like 6 days course, not 5, because the last day will be a full project. I'm gonna share the agenda with Iris. So Iris as well can share it with you. And we're gonna go through modeling to model for you your first model. Then we're gonna put more effort on tank, pumps, and valve. That's in day one. And then we're gonna show model calibration, steady state, model application, system design, manual. How do we design fire protection? And then other topics like criticality analysis involving extended period simulation, the pipe renewal planner and maintenance, automatic skeletonization, real-time data in connection with the SCADA, and then how to import the data, automated model calibration as well with the Darwin calibrator, and then we will go deeply into leak detection, optimized pipe sizing, and water quality. The course is going to be like 5 days and one more day optional for the final project. In the final project, we're going to get one of the data from Nairobi who could bring us few parts. So, well, In-Depth Research Institute is our training partner in Kenya. The course is planned for the first week of September, I guess, right, Mercy? Hello? And if you have any question, please let me know. All right. Can take like another 30 minutes?
Yes, we can. Thank you so much, Muhannad, for this insightful and practical presentation. Yes, that's been scheduled. So we'll share the dates once we have confirmed them and share with the participants.
All right.
Okay. Yes, I'd like the participants to also share any question that you might be having on the chat box. In this session, we've learned how hydraulic modeling can support network analysis, pressure management, demand for pump and reservoir optimization and asset planning. So we've also seen the value of creating a digital representation of water network that enables
Merci. I think you
You can get
Yes.
outcomes not just from understanding the concepts, but also being able to apply them effectively in practice. Why we have the training scheduled in September. That's Muhannad has mentioned. So to share more about this upcoming training opportunity and how you can participate, I'd like now to invite our Business Development Officer, Mr. Evans, who will take us through. Thank you.
Any other question? All right. So please.
Okay, sure. We have training scheduled for the 14th to the from the 14th to the 8th from the from the 14th to the 19th of September, and then for sewer gems we have them from the 21st to the 24th of September.
Uoneka kitu kiangalia hapo. Uoneka na Nancy. Kompyuta imehang.
Thank you so much, Evans. I think as you've heard, we have a training planned up in September where you're able to plug in and learn more about water gems and sewer gems. So
Sina ile stream. Video. Sina ile nafanya.
Also connect with us on our LinkedIn, on our Facebook, on our YouTube, all our channels, so that you're able to stay updated with what we are doing.
Sasa tukiangalia. Okay. Mmaliza.